This is the second in a series of companion videos for the DeepSpace Storage QuickStart Guide for Ceph environments. In the first video, we completed the installation of all of our software components on hostname Alfalfa. And in this video, we'll start by connecting to the browser for the first time using the HTTPS port. And you'll notice that we get a certificate error because we're using a self-signed certificate. So we'll have to go ahead and accept the risk and push through and connect. Now, in terms of user credentials, we, in the last paragraph of the last page of the QuickStart guide, pointed to a file. It's user local DS library and ops. And that contains it's basically the equivalent of sudoers for a storage operator. So the one user that is always configured is the root user. That is what ships when the package is installed. If you want to add additional user IDs, just add them one line at a time, one user per line, and you'll be ready to log in with a non-root user ID. But for right now, I'm just going to go ahead and log in as root. All right, so the purpose of this video is going to be a demonstration of information lifecycle management using our software. But before I can do that, I have to do a very basic configuration. So the two aspects of configuration that have to be performed is number one, outlining the storage environment by entering the hosts and the file systems. And then secondly would be to create a data management policy. And in this case, I'm just going to use a very basic one. It'll be a disposable policy. It's certainly not one I would ever recommend in a production environment, but it'll suit our purposes. So first of all, we have under the major tabs here, the bottom one being the configuration tab. So underneath that, a little bit more than halfway down, well, actually, before we do file systems, we have to add the host. So I'm going to go ahead and picking that host sub tab, just add this host name. And we'll need the DS, SMS, and RPC processes running. So I'm going to check these boxes to make sure that we're monitoring them within the dashboard. This max data movers is a per host, how many data movers can be spawned. So I'm going to change from the default to 2 to 20, and then we'll save it. Okay, now we're ready to come down to the file system sub tab underneath the configuration main tab. And I'm just going to create one. When you click on the hostname box, it should give you a list. In this case, it's a list of only one. And then I'll create my test one mount point, and everything else can remain the same. So this takes a moment. We use a systemd template. So these processes that are necessary to manage the file system will be started and enabled so that they're restarted on boot. Okay, so now when I return to the dashboard, you'll see that we picked up the DS, SMS, and RPC process monitoring here. We also have status controls, so these buttons just basically do system cuddle, stop, and start on those three processes. You'll also notice that we have the 20 drives that we created in the first video during the installation of our software. So now it's time to move on to a very basic data management policy. So first we have to have a file filter. A file filter is what we pass file system events through to determine whether or not we're going to take any action against them. So there is one pre-configured file filter, and that's the default. And it performs regular expression against the path, but in this case, it's not much of a regular expression because it matches everything. I could constrain this to an individual owner or group, but I'm just going to leave the default of any. Then the next thing that we need is a target. So we need to create a volume set within the catalog service. And I've already got one. We'll just go through some of the options here. So the name is arbitrary. I just call this one default VS. It has to have a configured pool. There is only one pool configured, that's root alpha P. We also created that in the first video. The file label type is file HSM by default. That is one of our standard label types, but it has some of the individual records within the label locked down, so they can't be modified by the user. The volume set also has a default owner, group, and mode, and it has a media type. So this is the type of technology that we're going to archive to for this volume set. So there's a bunch of different options. Right now, just tape and Rados, but we'll be adding some additional options later. And lastly, we have the expiration policy. So you'll notice that all these are grayed out. That was one example of one of the records that we locked down in the HSM label type. And the reason for that is generational expiration is really the only type of expiration policy that makes sense in a file system context. So this value can be anywhere from 0 to 9,999. An expiration policy of 0 means that whenever you create a new generation of a file, every generation that preceded it is expired. So you can do that up to 10,000, at which point it would roll over. Oh, there's one other attribute here, and that is the site location that has a context within remote vaulting. So we're not going to discuss that during this video. But anyway, that's the volume set configuration. Now, lastly, what we need is a policy that will link the volume set and the filter to a file system and an action. So let's go under the configuration main tab to the policy subtab, and we'll create a new policy. And here we'll choose the archive to the DeepSpace catalog manager option. So again, we're going to give it an arbitrary name. And on the target volume set, there's only one in existence. On the source file system, there's only one that we've defined so far. And on the file filters, there's only the default that we just looked at a minute ago. So we'll go ahead and save that policy. So we are now running a data management policy on the one configured file system on this server. And now I'm going to go ahead and grab some files to test with, and we'll get into the demonstration of ILM, or Information Lifecycle Management. So if you want to follow along with the same test data that I'm using in this demonstration, you'll want to go to our webpage at deepspacestorage.com and scroll down to the bottom of the page. Under Resources, you'll see a tab for DeepSpace Forum. In order to access these files, you will need to join and log in. Otherwise, you can see them, but you can't download them. So if you come down to the files referenced by DeepSpace docs on the bottom, there is a post called test files. So this test.tar.gz is what you'll want to download and expand. So I've already downloaded and uncompressed and extracted that file. And it extracts to one file and one subdirectory. So I'm going to change into that TIFF subdirectory. And what we have are 10 generations of a similar file. I'm going to run the display command to render a couple of these so you can see what I've done. Display command is not installed by default. It's part of the ImageMagick package, which has kind of a strange spelling. So if you want to do the same thing I'm doing, what I would do is suggest that you run yum provides display, grab the name of that package, install it, and then you'll have this command. So what you'll see is I've created a TIFF image that's got our logo, and embedded in the image is the generation in a text string. So you can probably see where this is going. I've got the incremented generation embedded in each one of these images. So I think that's enough. What I'm going to do is I'm going to start copying these files one at a time into the test1 file system, and I'm going to name the file foo. So what you'll see occur here is we create the volume set when the file is created in the file system. Data management policy picks it up, does a lookup to see if that default VS volume set exists already. If not, he creates it, and then he archives the file to it. So let's see what happens when I overwrite that. So you see we create another copy of the file inside of the catalog service. And we continue to do that. And what I'm going to do here is I'm just going to go ahead and create enough generations to start having some expired files. You may recall when I created that volume set, I chose the default to keep 5 generations. So we're going to overflow that so that we can discuss the process of dealing with expired files, running volume set reclamation, and recapturing our free space. Okay, I think that's enough. So let's just go into the test1 subdirectory or file system. And so I've got the one copy of foo. If I want a display command on it, you'll see that we're at the generation 8. What happens is every time we write a file into this managed file system, if it matches a policy, it gets written to the volume set and the generation gets incremented. And as a part of that process, a couple of things happen. One is we get the additional copy inside the catalog set. The other is that we create an entry in the file system sideband database that has all the file system metadata to record that committed change to the file when we overwrote it. And the other thing is we write extended attributes that we call an LCR, which is logically complete reference. So if I run SMS LCR on that file, so these are extended attributes. Each line references another generation. So the bottom line was the first one that we wrote. It was the first archive copy of this file. And what we've recorded here, well, the important portion is this is the file ID we created in the catalog namespace for the file. And what it breaks down to is the first string here is the UUID of the file system. Then you have the pipe character, and then you have the kernel handle, this string right here for the file. So We also record the volume set that we've written it to, which is default VS with root ownership, generation 0. And we record it on each one of these LCRs, the generation of the file, along with the byte count on the file. So this now gives me the ability to do something interesting. And I should also point out, there are some aliases that are installed when you install the DSCM package. One of them is called gens, and that's a more user-friendly view of the LCRs that are attached to this file. It just shows you the generations. Another one is the rewind command, so I can do, let's just say the rewind. Yeah, let's go back. It helps if I file name. Now, what the rewind does is it resets, it reorders the stack of LCRs. The one at the top is always the one that will correspond to the active state generation currently in the file system space. Since the file system can only accommodate one generation at a time, it's going to always be that one that's at the top of the stack. So we reordered it, and we also did a purge on it. Normally, after a purge, the resident remaining stub will be 4K with an XFS file system that was made with all the default. In other words, if you just do a make fs-t XFS, choose all the defaults, don't change anything. The default disk allocation unit is 4K. And most of the time when we do a purge, the only thing that will remain resident after the purge is 4K. However, if there's a lot of extended attributes attached to that file, and in this case, obviously, we've got 9 generations, that'll typically roll over and will have to leave the first 2 disk allocation units, which is why this is showing 8K. But the interesting thing is the file isn't resident other than a stub. I can still work with it just as if it is a resident file. So you can see what I did is I rewound this from generation 8 to generation 4 and made that file resident again. Now it's back to 52 kilobytes. So that's one of the first aspects of the data management lifecycle that I wanted to demonstrate, the fact that we version control all these files as we overwrite them. And we also provide a facility using the purge to relinquish the occupied capacity that file is taking up, with the exception of its metadata. So this wasn't a real big saving in capacity here, but obviously, if that had been a multi-gigabyte file, I would have reduced it down to either 4 or 8 kilobytes of resident space in the file system. So when we get into talking about free space policy, that's basically how it works. It'll look for the files that can be purged based on having had the oldest access characteristics and being ordered by capacity. So it'll look for the best targets of opportunity to release. In a CEPH context, as an archive tier, it doesn't make a lot of difference if a file is resident or in stub state, particularly if it's a small file, because the recall is transparent and it happens very quickly. But if you're doing an archive to tape, for example, there's going to be a latency of a moment or so while the robot accesses the tape, puts it into the drive, it gets to mount point, and then positions to the file so it can be staged back into the file system. So when you do the free space policy, you want to look for the things that you're least likely to need again in case your current archive tier is a high latency storage tier. So that's why we're selective about what we release. All right, so with that said, it's time to move on to the catalog space and show you that we've now got some expired files and how we clean them up and reclaim that free space. So what I did is I came under the catalog service and I selected volume sets underneath that tab, and it shows me I have just the one volume set. And if I open that up and do a file listing, it shows I have just the one file, but it's got 9 generations of it. So what you'll see is the latest generation, generation 8, and 7, 6, 5, and 4 are all current, but the earliest generations, 3, 2, 1, 0, are all expired. So they're still taking up room in the catalog service, but they're expired. And in order to free up that space, what we're going to do is run the reclamation job. So reclamation, let me go over a few of these options. Run on host is, we do third-party copy for this process. So basically the way the process works is we allocate an IO stream for the generation 0, in this case, volume set, which is the source. Then we allocate another IO stream for the next generation that we'll create during this process, which will be, in this case, generation 1. And those stream allocations can be on any host that has the DS software running on it. So in a case like this, it's not going to make any difference. But if I had, for example, my target was a tape target, I would want to run it on, if it was a SAS attached tape, I'd want to run it on the specific host that had the SAS attachment. If it was a fiber channel attached tape, I would just want to run it on a host that had a fiber channel port on the SAN that that tape drive sat on. If I don't do that, it's not a problem. It won't fail. But what the system will have to do is open up an IO pipe to the host that has the physical channel attachment. So he'll have to actually push each one of the files across the IP network when he could have instead just moved it across the channel attached network. So obviously the latter is always most desirable. The transcribe and keep original is typically done in the context of wanting to create a export volume set. So obviously this volume set being on CEPH, I can't, put it in my pocket and walk out of the site. But if I did want to create an exportable copy of it, I could do that with this option. I would just tell it to transcribe, keep it original as yes, and then I would set the media type as LTO, for example. So that would cause the non-expired files to be read off of the generation 0 volume set. Then a generation 1 volume set would be created that's allocated to a LTO tape cartridge. It would copy the non-expired files from the CEPH cluster over to the tape cartridge, and then it would leave the original G0 generation alone. It wouldn't scratch, and it wouldn't scratch it. So, your expired files would still remain in the catalog. But you'd have now a physical piece of media that you can export and take offsite if you want. The rest of these, well, before I move on to that, I skipped over the run rearchive. That brings up a particular operational mode that you want to be cognizant of. If I had a volume set that had enough generations to have some expired ones on there, and I happen to have an expired generation that was currently resident as the file system copy, the last thing I would want to do would be to run this reclamation and expire that file in the catalog, because it would make the version of the file that's in the file system an orphan. So we never want to do that. So what we do when reclamation runs, the first thing it does is a check to make sure that none of the expired files that it's about to release are members of any of my managed file system as the current resident generation. If it is the current resident generation, it will just skip the job and tell you that you have to run the rearchive. So in that case, you come back into this reclamation form and you change the Run Rearchive tab to yes from no. What that would do is it would touch every one of the files that fails that test, causing a new generation of an old file to be created. So if I had 8 generations of a file and the one that was resident was an expired generation, it would touch that file, causing it to be re-archived. So you now create a 9th generation of the file that's actually a copy of an older file. So that has the implication of pushing the expiration stack down one more, causing you to lose another file because you're taking that latest generation place for an old version of the file that you just re-archived. So that's just something I point out so you can be cognizant of. It's not going to let you do anything bad, but you will wind up with 5 generations in this type of a situation. And one of those generations is going to actually be an older generation of the file because of the process that we did to avoid having an orphan. So the rest of these attributes have to deal with the new volume set target that I'm going to be writing to. So I could change the pool, I could change the ownership, I could change the site location, and most importantly, I could change the media type. So if this particular volume set only had older data on it, and that data no longer merited placement on a Rados tier, I could deprecate that storage tier to say an automated tape tier, and everything would continue to function. It doesn't change anything operational. The only thing that you'll observe is the tape tier obviously having a higher latency property. Well, when you recall it from the catalog, it'll take a moment and a half to let the library do the mount of the cartridge and position to the file, and read the file and stage it back to the file system. But everything else functionally works the same way. So now I'm going to go ahead and run that reclamation process, and I'm going to leave it on the same media type. I'm not going to change any of these attributes here. I'm just going to run the job. So it finds the expired files, and it goes back and it does this test. It does a query against each one to make sure that none of those expired files are the resident copies. So it's gone ahead and created another generation of that volume set, and it's read just the non-expired files, and it's copied them over to the next generation. And then the last thing that it does is it comes in and it does a cleanup of the LCRs in the file system space. So if we go back and look now, and we do a gens food presently, you'll see that I removed all of the older generations, and I stripped off the LCRs that pointed to them. So now I no longer can rewind any of those files. They're no longer in the catalog. The space has been reclaimed, and the pointers in the file system have been removed. So at this point, make no bones about it, those file generations are gone and they can't be recovered. So that's the data management lifecycle. So just to summarize, when we attach a policy, we attach a volume set through that policy to a file system. When files get written into the file system, if they match the filter that is associated with that policy, they'll go to be copied into the catalog data service using the volume set that we defined. The file will inherit the generation data group properties of the catalog service. And as the file is overwritten over and over again in the file system space, the generational count in the catalog data service will be incremented. We can at any time rewind to anything that's any prior version of the file that's in the catalog. And eventually we'll get to the point where we have some copies of the file that are expired generations. So we run through the reclamation process to eliminate those copies and reclaim the space. So with that, I'm going to end this video, and we'll go on in the next video. I'm going to get into data management policies and show you some of the additional capabilities of the system. But hopefully by now you understand the management lifecycle, and we can start to move on to more interesting topics.